Okay. Bismillah ar-Rahman ar-Rahim. Now, inshallah, we have this part 3 of section 4.5. That was the last one we did. So now let me go to the next one. If I substitute, I have what? Minus infinity. This is infinity plus infinity. So minus infinity plus infinity, it means we need to do something. So the same thing, I'll make it over 1. Rationalize. This should be minus. So that will be what? Limit. This goes to minus infinity. 4x squared minus 4x squared minus minus, that will be plus x. Over 2x minus this. Yeah. This is cancelled. I'll do this usual trick. I'll take x. This one will be 2x minus square root. I'll take x squared common factor. You have what? 4x 4 minus 1 over x. And that will be limit. X goes to minus infinity. X, this is minus infinity, don't forget. 2x minus the square root x squared, as usual, is absolute value of x, and that will be minus x since I'm going to minus infinity. So this is minus, let me make it in steps. That will be minus x, so that will be minus times minus plus. I'll take x common factor. I'll take x common factor. The remaining is what? 2. That will be minus x plus square root 4 minus 1 over x. Cancelled. You have 1 over 2 plus 2, which is 1 over 4, which is this answer. You want to find for this function limit as it goes to infinity, limit as it goes to minus infinity. One they call it L1, the other one call it L2. You want just to see the difference. So we'll start with one of them. That will be 3x minus 2 over square root of the x squared common factor. It will be what? It will be 4. Yeah, 4 plus 5 over x squared. Okay. Which is square root of x squared, as usual, absolute value of x. The absolute value of x. I'll do the other side. This is take x, 3 minus 2 over x, over what? This is square root x squared, which is absolute value of x, 4 plus 5 over x squared. This will be the same. Infinity minus infinity will be the same. So I'll continue from minus infinity. I'll make this minus x. Cancelled, huh? This is cancelled. You have but no need for a limit. I can do it right away. That will be 3 minus 0 over the square root with a minus sign, 4 plus 0. Okay, so that is correct. Yeah. This is cancelled. I have 3 minus 0 over square root 4 minus 0, which is minus 3 over 2. Yes. Let me check now as this goes to infinity. I can start from here, from this one. Since this is, I did it for the same, but this will not be minus x, it will be plus x. So I have x, 3 minus 2 over x. This will be x square root 4 plus 5 over x squared. Cancelled, substitute. You have 3 minus 0 over square root 2 plus 0 over square root 4 plus 0. Okay. Yeah, square root 4 plus 0. So that will be 3 over 2. So this is L2 and this is L1. So I have minus 3 over 2 minus 3 over 2, which is minus 3. So this is will be the answer. This one I want to check how many verticals. Verticals, that's the denominator. Also add 0. We have a problem here. We need to be sure. So it will do it. Actually, x equals 0. I have 0 here. So how to check the limit? I think I need to do it as a rule, but it's okay. Consider it. And I have len x equals 0. That implies x equal e to the power 0, which is 1. So I have two vertical asymptotes. X equals 0, x equals 1. You can also check it through the limit. We are concerned about the horizontal asymptotes. Okay. So limit x goes to infinity for this function will be 1. If you notice the len, this is the len. Yeah, this is len x. So as x goes to infinity, the function goes to infinity. So this is infinity, this is infinity, 2 over infinity, which is 0. So the limit here is 0. If I want to check limit x equal goes to minus infinity, I cannot do that. Why? Because x is negative. The argument of len cannot be negative. So this is we cannot do anything here. So we have only how many horizontal asymptotes? Only 1. So 2 vertical and 1 horizontal asymptotes. Now he tell you y equals 0, y equals 5. He give you the asymptotes, but he put variables here. A, B, who cares? So first I need to simplify this. AX plus B over AX over 2AX plus 3 over AX. So that will be what? A e to x plus b over ax over 2 e to x plus 3 over ax. So this is cancelled. So I have a e to x plus b over 2 e to x plus 3, which I think it will be easier to deal with. Now check the limit as it goes to minus infinity, which is usually easier since I make this 0. خلاص. So it will be a times 0 plus b over what? 2 times 0 plus 3. So that will be b over 3. He said be positive. So this should be positive. He gave me one of the values y equals 0. So I have y equal b over 3 is a horizontal asymptote. Notice, I will take 0 or 5. I cannot take the 0. Because if I take the 0, that means b equals 0. But he said b should be positive. So it means b over 3 should be equal to 5. So b equal 15. Now we'll do the same for goes to infinity, which means I should get 0. Okay, so let me check what will happen to A. I have this function. I'll do the usual trick where I will take common factor, e to x. It will be a plus b is minus 2x over e to x. 2 plus 3 is minus 2x. Cancelled, substitute, you get a over 2. This one will be 0. As it goes to infinity, it will be e is minus infinity, which is 0. A over 2 equals 0. So that means a equals 0. So I have 5 times 0 plus 15, which is 15, which is this. Now this one, if you notice, it can be done using what? It can be done using the using squeeze theorem. I know cosine x is between -1 and 1. 2x plus cosine x is between 2x minus 1 and 2x plus 1. 1 over. It will be 1 over 2x minus 1. And this is 1 over 2x plus 1. No. As it goes to infinity, yes. As it goes to infinity, this is 1 over infinity, which is 0. And this is the same thing, 0. So that should be 0 by sandwich theorem, by squeeze theorem. So this will be 0. This limit, if you let t equal 1 over x, what you will have? This limit will be limit sine t. That means x is 1 over t. So this x will be 1 over t. And as x goes to infinity, t goes to 0. If it can be from right, it's okay. Limit t goes to 0 from right, sine t over t. And we know this. Limit as t goes to 0, sine t over t is 1. So this is the answer. This also is not a difficult one. Take the limit inside. What is the limit of this? Same degree. So the answer is 2 minus the limit. The limit of 2 is 2. The limit s goes to minus infinity of all of this. Which is 2 minus 1 over 3. This is same degree. Rational function, same degree. So it's 1 over minus 3. That would be 2 plus 1 over 3. This is 2 is 6 over 3. So this is 7 over 3. You want to do this limit. If you apply it to the minus infinity plus half infinity plus, plus infinity. So we can rationalize. This is minus. So that will be limit x goes to minus infinity, 9x squared minus 9x squared plus x. Minus times minus. So it will be plus x over 3x minus this. So that will be what? This is cancelled. The same thing which it did before. That will be x over, I take x common factor, I take here's 3x minus, here I take x squared common factor. I have 9 minus 1 over x. Okay, check 9x squared minus x. Yes, correct. So now the same thing, I have square root of x squared is absolute value of x, but in this case it will be minus x. I'm going to minus infinity. So that will be limit x goes to minus infinity, x over 3x. This will take it minus square root x squared, so it will be minus absolute value of x. Let me do it in steps. And that will be limit. This is minus x. So it will be limit x goes to minus infinity. X, I will take x common factor. I have minus 9, this is plus. So this is 3 plus 9 minus 1 over x. X cancelled. You have 1 over 3 plus 3, which is 1 over 6, which is this. The product case for which y equal k is a horizontal asymptote. Horizontal asymptote, we either check the limit as goes to infinity for this function. X goes to infinity, so absolute value will be positive. That will be x over x plus 1. I know that is 1. Check limit x goes to minus infinity. Okay, so the absolute value, the argument inside the absolute value is negative as it goes to minus infinity. So it will be go out as minus x over x plus 1, same degree. So the limit is minus 1. What they want? The product. So product will be equal 1 times minus 1, which is minus 1, which is this. Now we'll go to the questions of the book. I'll do more than the suggested problems. This 5 to 10 problems, you can notice it quickly. He wanted to check the horizontal asymptote from the graph and from the function and match them according to the horizontal asymptote. Here I have horizontal asymptote y equal 2 from both sides. Here I have y equal 0 from both sides. Here I have y equal 2 and y equal minus 2. Correct? This is minus 2. This is 2. Here I have y equal 0. So this is the two are the same. Here I have y equal 2. Here I have y equal 4. Okay. In this one, the limit is what? Yeah, minus of this is y equals 0. Here, it will be y equal 2. And this one, it will be, this is 0. 0 plus 2, so y equal 2. Here, okay, I'll come to this one. This is y equals 0 again. No, here y equal 2, not 0. It will be 2 over 1, huh? Same degree. This is degree 1 over degree 2. Here it will be, the control will be here. This is the number over infinity, so it's still y equals 0. This one, yeah, by the way, this one, if we take the absolute value, x squared, this one will give you plus or minus 2. And when we take the absolute value, square root x squared, take the absolute value, minus infinity will give me x, plus infinity will give me x, minus infinity will give me minus x. So this is plus or minus 2. You can check it. This one, you have, actually here you have 4 and 0, huh? You have 0 also here. This one, as it goes to infinity, you have 4, and minus infinity, you have 4 over infinity, which is 0. I wish I'm doing it quickly, but just to match now. So actually, you wanted to graphs. No, not match it. So for sure, this one is here. This is 10. Plus or minus 2 is here. So this is C. 6, I mean. This is 0, 0. This is 2, 2. Okay, so which one? You notice this one is more than 2. 2 plus. Where this 2, it's below 2. This is more than 2. This is below 2. If you notice, this is 2 plus something. So this is for sure, and this is everything always positive. So it should be greater than 2. So this is should be 8. I'm trying to think of ideas how this one how to match them. This is 2, but it will be below 2 since this is x squared plus x squared. Yeah, it cannot exceed 2. Okay, so this is will be 5. Now the remaining these 2, you can take a value. Sometimes you can take a value, it will help. So I need to match it, this or this. You can take, yeah, at 1, it's more than 1 here, and less than 1, more than 1 here, and less than 1 here. So take 1 here, it will be 1 over 3, 1 over 3, so this is will be 7. And this is doing something like sine, huh? 4 times sine 1, which is very small, over 2. So it will be something more than 1. Sine 1 is 0.001. It will be what? Oh, it will be this than 1, huh? This one, 1 over 3 is for sure. For sine 1. Yeah, sine 1 is not that small, huh? And sine pi over 2 is 1. So sine 1 is something not far from 1. So 4 times this, it will be a value more than 1. So this is will be 9. You can think of other ideas how to match them. But the idea know how to get the asymptotes from the graph and how we can match this and from the function. Let us go to the real things, which is the how to do the calculations. I know if that's clear, I can maybe I can do this, how to find the we'll do similar functions while we are doing the calculations. Okay, so let me move to 12. 12, I have what? I give you a function f, which is minus 4x squared plus 2x minus 5. And he's asking you, what is the limit as this goes to infinity of this function? Limit as it goes to infinity of the following functions. F of x over x. If you do this, you have what? Degree 2 over degree 1. So that, remember, we agreed that will be the same limit as this one. Minus 4x squared over x. Highest degree. This will be what? Minus 4x, which is minus infinity. Limit x goes to infinity. The same function, but over x squared. Oh, I have the same degree. So that will be the leading coefficient. Minus 4 over 1, which is 1. The last one, I have it, but over x cubed. Oh, now I have numerator degree is less than degree denominator, and that will be 0. This is the point of this section, of this problem. Now, he wanted to find the limit at infinity. Find different limit. X goes to infinity, x goes to minus infinity. So he wants you to find this for different functions. 14, limit x goes to infinity, 3 minus 2x over 3x cubed minus 1. Degree 1 over degree 3, that is 0. This is, it has different parts, A, B, C. So we'll do all of these parts. This is A, B, limit x goes to infinity. Same idea, 3 minus 2x over 3x minus 1. And that will be what? Same degree, so it's minus 2 over 3. C, limit x goes to infinity. 3 minus 2x squared over 3x minus 1. This is different degree, so I will take this over this, which is limit x goes to infinity, minus 2 over 3x. And that minus 3, yeah, x. So it's minus 2 over 3 times x, which is minus times infinity, which is minus infinity. This is 14, 16, same idea. You want to do this with these functions, limit x goes to infinity, 5x3 over 2 over 4x squared plus 1. This will be 0. Why? Because this is less than. You can divide by x squared. You can do it by this way. Since these are fractions, it will be the same idea. Over x squared. And they divide here by x squared. Usually divide by the highest power in the denominator. That will be 5 x to the power minus half over 4 plus 1 over x squared. So now if we apply the infinity, this is the limit. This is the limit. Apply the infinity, you get what? 1 over x, 1 over square root of x, which is 0, over 4 plus 0, which is 0. As I said. This is part A. Part B, limit x goes to infinity, 5x3 over 2 over 4x3 over 2 plus 1. If we divide by x to the power 3 over 2, it's very clear. This is 5 over 4 plus 0, which is 5 over. See, limit x goes to infinity, 5x to the power 3 over 2 over 4 square root of x plus 1. If we divide by square root of x, you get what? Limit x goes to infinity, x to the power 3 over 2 over x to the power half, that will be x. And this will be 4 plus 1 root of x. as it goes to infinity, you have what? This is infinity over 4, which is infinity. So these are these problems. Now we have finding limits. This is, we have a lot of many problems. We'll start with 16. I will do for sure the suggested problems and more. Not 16, 17. I mean, we're done with 16. 17, which is an easy one. Limit x goes to infinity. 4 plus 3 over x. Distribute the limit. This will be 4. 3 over infinity, which is 0. So I have 4. 18. Limit x goes to infinity. 5 over x minus x over 3. That will be what? 0 minus infinity, which is minus infinity. This is 18. Plus, this is 18. Oh, it's minus infinity, sorry. X goes to minus infinity, not infinity. I will do also for minus infinity. Limit x goes to minus infinity for the same function. 5 over x minus x over 3. It will be what now? It will be 0 minus infinity, which is infinity. Actually, this is the question 18. This is, let me call it 18 hat. Since I did it for x goes to infinity, but the problem is the same. Now we did 17 and 18. I'll do 23. X goes to minus infinity. Yeah, 23. Limit x goes to minus infinity. Minus 4 over 3 plus 3 is minus 2x. If you apply the infinity, you have what? Minus 4, 3 plus 3. This will be infinity. It's infinity minus 3 over, yeah, as a limit. Huh? Yeah, this is goes to. So this is minus 4 over infinity, which is 0. This is 3 times infinity. You can do this. 24. Limit as this goes to infinity. 6 over 5 plus 2 is minus 4x. So if I plug infinity here, I have e is minus infinity, which is 0. So that will be 6 over 5 plus 2 times 0, which is 6 over 5. Okay. Yeah, I'm doing these problems. Now I'll do something like this. Different functions. 26. Limit x goes to minus infinity. X over square root x squared plus 1. We'll do this trick, taking the common factor. X. This is, I'll take x squared. 1 plus 1 over x squared. And that will be what? X, this is square root of x squared, which is absolute value of x. That will be minus x. Cancelled. So you have 1 over minus 1, which is minus 1. Okay. I'll move 27. The same idea. 2x plus 1 over square root x squared minus x. But I need to take common factor also in the numerator. We take x. I have 2 plus 1 over x. Over here, I take x squared. 1 minus 1 over x. And last, this will be the same thing as square root x squared, which is absolute value of x, and that will be minus x. So that limit will be equal. Limit x goes to minus infinity. I'm doing this will be x 2 plus 1 over x over this will be square root of x, which is minus x square root 1 minus 1 over x. Cancelled. Substitute. It will be 2 plus 0 over minus 1, which is minus 2. Now we'll do the next one. 28. Same idea, but this is suggested problem. We'll do the same thing. Limit x goes to infinity. Take x squared, 5 plus 2 over x squared, over square root x squared, 1 plus 3 over x squared. Yeah, but now we have square root of x squared is absolute value of x is x. So x goes to infinity. So that will be x squared, 5 plus 2 over x squared, over square root of x squared, which is x. 1 plus 3 over x squared. Notice this will be what? Don't forget the limit. That will be limit x goes to infinity. This will be infinity. Let's take this. Substitute, you have infinity. 5 plus 0. This goes to 0. And this goes to 0. Over 1. And that will be infinity. That will be infinity. 30. Actually, you can think of it. This is degree 2. This is degree 1. 2 with the square root will be. So it should be infinity. If it goes to infinity or minus infinity, you need to check the sign. Limit x goes to minus infinity. Cube root x over 4 minus 1 over x cubed minus 1. I can argue this goes to 0. And you can check it. This degree is 2 over 3. But you can do it by this trick. Or common factor. You take x to the power 4. Will be 1 minus 1 over x to the power 4 over, I'll do the same trick. You take x cubed, 1 minus 1 over x cubed. So that will be what? Square root of x to the power 4. Huh? Let me put it here. Square root x to the power 4 is what? Absolute value of x squared, which is x squared regardless. I'm going to minus infinity or infinity. So this will be limit as x goes to minus infinity, x squared under the square root 1 minus 1 over x to the power 4 over x cubed, 1 minus 1 over x cubed. So this is cancelled. This will be x. So you have what? 1. This goes to. This will be 1 minus 0 under the square root over. This will be minus infinity times 1 minus 0. This goes to 0. This goes to 0. So you have what? 1 over minus infinity, which is 0. I think, and I will stop here.